OpenAI runs on Python. Google's Gemini runs on Python. Meta's Llama runs on Python. Anthropic's Cloud Python. Every single AI breakthrough you've heard about in the last decade was built in a language created by one man as a hobby project during his Christmas holiday in 1989. Python was never designed for AI. It was never designed for speed. It was never even designed to be serious. And yet it became the language that runs the most powerful technology in human history. Here's exactly how that happened and why no other language could have done it. December 1989, the Netherlands. A Dutch computer scientist named Guido van Rossum was bored during his Christmas holiday, so he started writing a programming language for fun. He named it after Monty Python's Flying Circus, the British comedy show he loved. Not the snake, a comedy show. His goals were simple: make it easy to read, make it feel like plain English, make it open source. Anyone can use it, anyone can improve it. On February 20th, 1991, Python 0.9.0 was released to the world. No company behind it, no funding, no grand plan, just one man's hobby project. Nobody had any idea what they had just unleashed. For its first decade, Python was popular but not dominant. Developers liked it. Scientists used it for scripting. But for serious number crunching, you used Fortran or C. Then in 2005, everything changed. A researcher named Travis Oliphant looked at the mess of incompatible numerical libraries in Python and decided to fix it. He combined the best parts into one library called NumPy. Released in October 2006, it became the foundation for every AI tool. NumPy introduced the AND die, a way to manipulate massive arrays of numbers at speeds that rival C and Fortran. One by one, the entire scientific computing ecosystem of Python was born, all because one researcher decided to clean up a mess. Now here's the part that surprises most people. Python is actually slow. Genuinely, technically slow compared to C++ or Rust. So how is it running the fastest AI models in the world? Here's the secret. Python doesn't actually do the computation. When you run a PyTorch model, Python is just the front door. The actual heavy lifting runs in C++ underneath. PyTorch, TensorFlow, NumPy, they are all written in C or C++ at the core. Python is what engineers call a glue language. It gives you a clean, readable way to control blazing fast engines. You get the speed of C++ and the simplicity of Python. That's why it won, but speed alone doesn't explain everything. There's another reason Python won, and it starts in university lecture halls. In the early 2000s, top AI research labs like Stanford and MIT were all teaching and publishing in Python. It reads like plain English. Then came Jupyter Notebooks in 2014. Suddenly, researchers could mix code, results, and explanations in one document. It was revolutionary. The academic world adopted Python completely. When those researchers graduated and joined OpenAI or DeepMind, they brought Python with them. Today, 80% of papers published at NeuroPits, the world's most important AI conference, use PyTorch, written in Python. So what about the other languages? Why didn't they win? C++ is fast, but it's like performing surgery with oven mitts. Too slow to iterate. Java is verbose and rigid, or is brilliant for statistics but narrow. It can't handle the full data pipeline like Python can. MATLAB is powerful but expensive and closed source. Julia is fast and elegant, but it arrived too late. Python's momentum was already unbeatable. Today, the Python AI ecosystem is the most powerful collection of open source tools ever assembled. PyTorch powers GPT and Claude. Hugging Face Transformers gives you 500,000 pre-trained models in 3 lines of code. LangChain connects them to the real world. According to Stack Overflow's 2025 survey, Python usage jumped to 58%, the biggest single-year jump in history. There are over 152,000 AI job positions requiring Python. The machine learning market hit $120 billion in 2026. Every cent runs on Python. And here's why this will never change. It's a network effect. Talent learns Python, so companies hire for it, so libraries get better. It doesn't reverse. Guido van Rossum started a hobby project during a Dutch winter in 1989. He had no grand vision, yet today it is the foundation of a revolution. That's not a plan, that's something better. That's the right tool in the right place at exactly the right time. If you found this useful, subscribe. I break down the real stories behind tech every week. Drop a comment. Do you think anything will ever replace Python and AI?